Are we really going to be flying traditional helicopters in 2050? Perhaps. I think this is a long, I said, I've been quoted, this is a long goodbye for helicopters.
Welcome to Hangar X Studios, where former fighter pilot and host John Ramstead takes us on a journey across aerospace as it enters an historic period of innovation and transformation. Our guests include aviation experts, pilots, financiers, military leaders, and innovators of all types. Buckle up for another episode of Hangar X.
Hey, welcome to the Hangar X podcast, where on this podcast we explore some of the most cutting-edge topics, insights, innovations happening in aerospace right now. And today we're going to be talking about transformation of part of the industry with Dave Stepanek. Dave, welcome to the podcast, first of all.
Thanks, John. I'm happy to be here. Really excited to have a discussion.
Yeah, and it was great. I know you met with my colleague Salim Zahir at the Revolution Aero Conference and had a great conversation. And everybody listening, Dave is the Executive Vice President and Chief Transformation Officer for Bristow Helicopters. And Bristow is one of the largest helicopter operators around in the world, doing a lot of work in the oil and gas, oil field services globally, search and rescue. And we're going to be talking a lot about that. And we're also going to be talking about, though, Dave is leading a transformation of bringing part of that fleet and the mission into what's happening right now with advanced air mobility, VTOLs, eVTOLs, and just a really exciting time. But with that, Dave, I would love for you to share a little bit about your whole career, starting back as a enlisted Marine, working on those big, giant H-53 monsters. Whenever I flew in one of those when I was in the military, man, I was just praying that I would land safely somewhere on a flat, piece of ground. But I'll turn it over to you.
Yeah, it's thanks. Thanks for reminding me. It's been a long career as well. It's been just, I just feel very blessed. I was fortunate enough to be excited about aviation as a young person, and I saw an opportunity to work in aviation through the military, and I decided to join the Marine Corps after speaking to recruiters with a guarantee to work in the aviation side of the Marine Corps. I was fortunately assigned to a CH-53 Delta Squadron. That tells you how long ago it was. There's two other versions of that aircraft out now. It's 4 years in the Marine Corps avionics technician. I got recruited coming out of the Marine Corps to work for Sikorsky. I spent 20 really great years at Sikorsky in various roles of technical service and support. Got to move around the world, lived in Japan, moved around the United States, supporting the U.S. military as a technical advisor. And then moved into the commercial side of the business in customer service, and then finally in the sales side, which really exposed me to the entire business sector itself, all the different customers, all the different aspects of building aircraft, designing aircraft.
And you got to drive the whole sales efforts of the S-92, is that correct?
I was part of that team, yes. I was there.
Because that was a huge success for Sikorsky.
Yes, it was, and it's been a huge success for us we're the largest operator at Bristow of the S-92s. So yeah, I was there at the very beginning. I sold the first one. That's my little stamp on history. I have a coin that was the first flight, and I have a coin that was on the 2 millionth flight hour. So it's really nice to see that evolution of that aircraft and being part of it. It was like a miniature CH-53 to me. When I came out of the 53 program and they said, hey, we got this really big helicopter for the commercial world. And I looked at it and was like, that's not a big helicopter. It's a medium-sized helicopter. But, as perception and reality is just, part of that whole process. So, yeah, Marine Corps 20 years, coming out of, Sikorsky for 20 years. I left Sikorsky, I was recruited to come into the commercial world with Secor and Era Helicopters. They owned helicopter at the time, and I was exposed to really the business side of leasing aircraft and placing aircraft around the world and supporting that type of operation. I did that for a few years and got recruited to go work for Petroleum Helicopters, PHI. They had one of their executives that was retiring. I was a natural fit for the chief commercial officer there. I was a chief commercial officer of PHI for a number of years and became the president of two divisions that were just kind of in succession, PHI Energy and then PHI Americas. did some acquisitions, started some businesses around the globe in various locations, Australia, Europe, Middle East. Really just exciting times. In 2020, Bristow was on the cusp of a merger with Aero Helicopters, or Aero Group at the time.
Yep.
Actually, Aero Group was merging and doing the acquisition post bankruptcy for Bristow. And I was asked to come over and be part of that process of the merger and integration, which I had some experience in. And I was fortunate enough to run through that merger, lead that side of the Aero side as merger integration leader. I became the chief operating officer of the combined entity post the integration in June of 2020, and then really integrated the two businesses in the United States, the SAR team in the United States, IT, supply chain. Got that done fast through COVID. Was really interesting time. We had a great team. We had really just everybody was pulling together. After that was over, and we discussed what we wanted Bristow to be like. What was our mission? What was our vision? What were our values? Well, our vision is to really be a leader in innovative. Our vision is to lead innovative and sustainable vertical flight solutions. And we started saying, "Oh,
So
how
clearly,
can we
as
do
an
that?"
expert, like literally an expert in all things helicopter, in the mission and the finances and the business models around that, you're actually saying, okay, that's just part of this picture, this vision for this company. Correct? Is that fair?
That's just part of it. And what's the future look like? What's the next 20 or 30 years look like? Bristow just celebrated its 75th year. We want to be around another 75 years. Are we really going to be flying traditional helicopters in 2050? Perhaps. I think this is I've been quoted, this is a long goodbye for helicopters. Helicopters have unique capabilities. They have really great missions. They're an amazing machine. But technology will advance. And we think that with the advancement of what we call AAM, Advanced Air Mobility, which I define as aircraft that are utilizing electric and hybrid electric propulsion systems and using somewhat unique airframe architectures, whether that's tilt rotor, tilt fan, ducted fan, all the things that go into it. I wrote a guidebook on it. You can see it on our website about the different technologies. That's what
we have a
AAM
link for
is.
that. If anybody looks in our notes, Dave, we'll make sure we put a link to that guidebook that you wrote.
It's a philosophical guide today because we haven't run it into operations, but we'll be operating an electric aircraft this year in Norway, starting in the second half of the year, to really prove out our theses around this advanced air mobility and electric propulsion systems. We'll talk about that more later. But what we want to lead that, and to lead that means we have to look at what other technologies are available. It's not just about organic growth with helicopters. It's not just about advancing. There are, back to, I mentioned Jeff Pino and his involvement with your company a few years back. He always talked about quantum leap in technology was necessary. During those days, it was really that the X2, the coaxial, the high speed, but the quantum leap's now coming in this advancement of electric propulsion systems. So yeah, it's small, it's limited, it's going to have short range, it's going to have low payloads, but it's the very beginning. And I say in the guidebook, that if the Wright brothers really sought out to fly 787s across the Atlantic Ocean in 1903, they would have never really got started. They had to start somewhere, right? We got lateral control fixed.
Well, and also think about this.
flying
Nobody
around
could even
farms.
envision a 787 when they were flying something made out of wood and fabric.
That's right.
So, a question
So
for you, though.
let's evolve.
Yeah, that's right. Let's evolve. So when you're looking at your mission, you guys are flying, from the S-92, right, with, a heavy or a medium twin-engine helicopter down to light helicopters, and your entire business model, assets around the world, and you're starting to look at this whole space of eVTOL, VTOL, advanced air mobility. What was your process to actually look at, does this actually add value to what we're trying to accomplish as a customer or as a company, serve our customers? What was that, maybe that thinking that you had internally to evaluate this?
Well, it's really two things. One, we have the expertise in vertical flight, which is very difficult to do and very hard to do. And because we have the expertise, we also have a global footprint. So we're a global regional airline. We have 14 operations. We operate in 19 countries. So where airlines might have one AOC and a 121 to fly over the world through the bilateral agreements, we have miniature businesses. Well, we have large businesses everywhere around the globe, and we think of that experience. We see this technology really as a parallel path to the helicopter world, not necessarily replacing helicopters. Maybe over time in certain missions, some aeromedical operations, some flight seeing operations where you could actually supplant helicopters today. But over time, it will happen. But we think it's a parallel path. So we can use our technology to help this industry really get up to the start line. And we got a lot of problems to solve. Everybody seems to be trying to solve problem 500, when we really haven't solved problem one yet, getting a commercial aircraft certified to fly in wherever we happen to get it certified. So we want to be part of that process and bring in some of our intellectual property, our know-how, to make sure this industry doesn't get started, because we think it's going to be a massive industry. We want to be part of it. We want to lead that process, but we know that we could help that along the way. Many of the companies that are starting these new companies, and many of them have been around for quite some time, it's their first time building an aircraft. They've never been in the aerospace industry before. They've got great people, great technologies, great ideas, doing it for a great reason, but they haven't operated helicopters or operated aircraft in a commercial world. And there's a lot of difficulties in doing that. And there's a lot of things that you're not going to see in flight test that happen in the real world of operating or launching a new product, whether you're launching a new S-92 in 19.
Well, question for you: if you're looking at from the mid-range VTOL like we're developing down to the short-range eVTOLs, what are some examples of that you guys were maybe considering? Like, here's something real life things we encountered flying helicopter ops that we have to be thinking about as we're looking at this new platform.
Well, so I'll start with when we started to select the platforms that we thought we could use early. So we looked at the technologies that was available. We looked at the team. We looked at the ability to get funding and the robustness of the aircraft. Because you start thinking about things the hazards that we see. Of course, low altitude flying, high intensity radiated fields, birds, weather conditions, turbulence, all the things that you see in low altitude operating in remote locations. Those are all the hazards, and then just a few of the hazards we have to deal with. Configuration of the aircraft, how it's equipped, what type of kit is on it, is it fit for purpose? Just because it's type certified doesn't mean it's fit for a certain commercial operation. It doesn't mean it's fit for all commercial operations. So all those things come into play. So we looked at the ones that we thought that we could put into some sort of commercial operation. And we looked naturally at our customer base. Our customer base, as you mentioned earlier, energy companies primarily. 65% of our revenue comes from supporting the offshore energy business. The other bit of our business comes from government services, mostly search and rescue. So we're the Coast Guard, United Kingdom, Ireland, the Netherlands, the Dutch Caribbean. How can we utilize this technology to support that type of operation? How can we utilize this technology to support our existing energy companies, which are fundamentally large logistics companies? They got to move a lot of stuff, a lot of equipment, a lot of people. They got to move it to and from their fields. They use a lot of different ways to do that. Whether one is helicopters, they also use a lot of trucks, and they use boats, and they use subsea vessels. Is there work there? And we think there's a natural fit. We believe that, back to the premise of early aviation, cargo first. When we first started aerospace 100 years ago, 120 years ago, we moved the mail. We moved some cargo around. We may have took the occasional farmer up to look at his field, but we were moving cargo first before we started moving people. So can we move cargo for our energy customers? Or can we move cargo for required missions where you have geographic barriers in place? Those sorts of things where the shorter range flights for electric aircraft can make sense. We also really are excited about the lower cost of operation and potential higher reliability of the components of electric propulsion. I mean, you take out all the complex bits of the helicopter, the transmissions, the mechanical flight controls, all the hydraulics to support that, the drivetrain, the high-speed shafts, the turbine engines. You reduce a lot of cost structure. You reduce a lot of heat. You reduce a lot of vibration, which should impart higher reliability of the components. So we think we can lower our cost structure, provide a service that's not necessarily there today. Maybe it's being supported by land vehicles, at a lower cost, at a higher sustainability for our customers. So that was the original thought process and
So
the
that was
business
kind of the
model.
premise. What did when you
Yeah,
looked at the data, what did you find?
we found that an equally sized vehicle, electric propulsion or even hybrid electric propulsion systems, is about 60% less cost to operate than a traditional helicopter. And what we're seeing in the CapEx side, so OpEx is lower,
Mm-hmm.
and CapEx sides right now is tends to be lower than helicopters. That whether that remains to be true, we'll see. Hopefully, with the higher production numbers, we'll see lower CapEx. So we see really an opportunity to provide really air travel where we couldn't provide it before because helicopters were either too expensive or there were some other uh, public perception issues, cost, noise. It's only for rich people kind of thought process. So hopefully that the democratization of electric propulsion system will happen, and we think that's really going to be a unique attribute for it. But
So
our view is pragmatic. Start slow, start short range, start with cargo, prove it out to ourselves because just because the airworthiness regulator certifies it, we have to prove to ourselves as an air carrier safe, reliable, and efficient. Can we do it fit for mission? And if we can do that, then we can start to prove to the regulators to allow us to expand the applications, expand the use case, and then by virtue of that, we'll gain the public's confidence.
question for you, because you talked about kind of low altitude ops, weather, turbulence, all those things. Is there any consideration for you on whether that aircraft needs to be certified IFR or some of the ones right now that are coming out that are going to be VFR only? How do you think about that and what that means to you from a business case?
We think there's got to be a path to IFR to be a sustainable commercial model. We would fly VFR first only. We're going to fly piloted aircraft. We're not making any business plans around autonomy except for the Elroy Chaparral, which will be remotely piloted. And we do a bit of autonomous flights for a search and rescue program in the United Kingdom. But we think that VFR first, but path to IFR, and you're going to have to sort out weather conditions, icing and snow and rain and sand and all the things that we'll have to deal with. So that's one of the reasons we looked at specific vehicles. And I mentioned in an earlier conversation, at the end of last year, we were fortunate enough to be awarded a letter of intent from the Norwegian Civil Aviation Authority and EASA and Avinar to operate in a regulatory sandbox test arena, so a European test arena for zero and near zero emission aircraft, which we will be working with Beta Technologies. We're building out the final concept of operations right now, which means we're going to operate a conventional takeoff and landing 100% battery powered aircraft in Norway for 6 months, and we plan to operate and fly that aircraft VFR, IFR, night, day, and in all weather conditions. See how
And so this is a conventional takeoff, not a STOL or
conventional takeoff
VTOL,
first.
correct?
Conventional takeoff first, yes.
Where are they going to fly that out of in Norway? Because my whole family's from there, by the way, so I'm just curious.
We'll be based in Stavanger.
Oh, sure. My uncle used to be the harbor master in Stavanger, believe it or not.
Beautiful city.
Beautiful.
We're the largest helicopter operator in Norway. We have about 450 great employees there, several bases along the west coast of Norway, all the way up through the Arctic Circle. And we'll be working on just local flights, then some regional flights between Stavanger and Bergen, and then expanding that as we prove out the technologies. I mean, one of the really interesting things, I was listening to one of your podcasts earlier, I think Sergio mentioned this, talking about the fact that your energy source is you can't really trade your payload off for energy, right? So your
Not
energy source is
when
always
you're
there.
electrified.
Yeah. So what
Correct.
that means is we're going to take off and land at maximum gross weight almost every time,
Correct.
which is very unique. And I mean, when you think about what's going to be required to do that, not only are we going to take off and land at maximum gross weight, we're going to do it multiple times a day or multiple times an hour to meet these business plans. Can this aircraft really do it? Are the components going to be able to handle that? Have we built in enough robustness? All those things we're going to have to sort out. And then what's it going to look like for battery conditioning, different charging and different temperatures? How fast is it going to work? What's the reliability of the motors? What happens when you put it in a salt environment? All those things we're going to learn in this process to allow us to build, either build or say, nice shot, but we got to go back to the drawing board. But we think we've got a real winner with the beta team and really all of our other OEM partners for this beginning.
Yeah, it's exciting, and it's gonna be interesting to watch. We'll have to have you come back on and update us as you're learning more and more. But I do have a question. If you're just kind of looking at what's happening in the industry, with Liliam, Volocopter, some of the other news, right? There's great news, and there's also some news that makes you pause and think. How do you think that might affect either certification timelines or capabilities or other impacts that you're looking at from a business model?
Well, with Liliam and Volocopter, I mean, two really interesting companies. I had a chance to work with both of them. I visited their facilities. I've seen both aircraft fly. Really unique in nature. So here you have these really great companies that start up. Somebody had some great ideas. They were able to raise a lot of capital and get something going, and then ran out of cash. That's what it really boils down to. So cash is king in this business. It's really hard. It takes billions of dollars, which everybody's learning. There's no shortcuts. So the regulatory agencies need to stay on path and say, hey, there's no shortcuts. Just because you're sustainable or you think you're cool doesn't give you a shortcut to certification. You got to prove everything out. Mm-hmm. There's no, back to Sergio's, he talked about, a car, you drive into the wall, it gets a B or a C, you still can sell it. You can't do that in aviation, nor should you. I mean, this is really, really hard. So I have I think very highly of both the Lilium team and the Volocopter team, their leaders and the companies that. I'm sad to see that they've had the difficulties they've had. I don't know if through the insolvency of Volocopter they're going to get refunded or not. I hope they do. Same thing. Lilium got some money back in. They still are going to need a lot. But it shouldn't. What it shouldn't do is it shouldn't affect the thoughts of the regulators. They need to stay the course, and the aircraft need to be certified under the conditions which what's been prescribed, whichever they're doing at EASA or FAA or ANAC. And how we look at it at Bristow is because we're not building these things. People always ask me, what are you in this? We're an air carrier. We're going to buy a bunch of aircraft. We're going to buy different types of aircraft, and we're going to operate for the missions that we prescribed. And in many cases, we'll operate a variety of these different vehicles within a network, just like any other airline does.
That's right. As a business, you're going to go evaluate what is available, what fits my mission set. Can I serve my customer and make a profit?
Correct.
And if all those line up and it's good technology that is reliable and safe, then we have something we can work with.
And we're going to try and do that with investing as little capital as possible to try to prove it out before we take these risks. What we're risking right now is really a lot of our intellectual property and our time and effort. We put little bits of capital in here and there, but we're not going to go through this until we know we're going to be at a point where we can make this a viable commercial model. The data tells us we can, but we still have to prove it out in operation. So I don't, and then when things get delayed, then it's time. It's certainly a challenge for us, but we don't have that capital risk that the vertically integrated companies have, or any of the other OEMs will have as they're progressing along. Whether they're just a traditional OEM such as Beta, where they're going to sell the aircraft, or if you're completely vertically integrated such as Joby. I really admire all of the different business models that people are coming up with, and I hope that if this industry proves to be successful in its size and scale, there's a lot of room for a lot of different types of vehicles and a lot of different types of business models out there.
Yeah, there is. And question, I was thinking, as when you're looking at an electrified plane like in Norway or even just another VTOL, always taking off and landing at max growth weight. You do a lot of operations in the Middle East. I've been to Dubai. I've been to Abu Dhabi. I've been to Iraq. It's a bit toasty there. So it's hot, toasty, high, and humid. If you're in those environments, or even very frigid environments like Norway can be, because that's going to affect the battery life. What are some things you're thinking about? Do you have any anecdotal data on how these platforms might perform, or what % degradation might happen when you have any kind of weather extremes?
Well, just thinking about helicopter degradation, both the turbine fans and the main rotor blades and tail rotor blades, in a desert environment, an area where you have corrosive environment or it's sand, whether it's the Middle East or West Africa, you see a 30%, 35% reduction in the life of the components. It's just erosion. And these are really robust components. So if you've operated aircraft and helicopters in the Middle East, many times you'll put a polyurethane, like almost like a paint protective film that you put on a car, a polyurethane strip along the leading edge of the main rotor blades, and you're paying a higher price to whichever engine manufacturer you have for your engine program, or you're having a lower useful life to overhaul of the engines. Those are facts. So that's until you figure out how to reduce that down, and if you have to put an engine air particle separator or some sort of barrier filter on the turbine, or if it's a ducted fan, then you're reducing your power. You're therefore reducing your performance. So those are the challenges you're going to be faced with in places like the northern territories where you have icing conditions. That's going to cause higher weight and higher power requirements, therefore reducing your performance, whether that will be viable or not. Those are all things that have to be dealt with.
Here's a question. Maybe you know it also. It's a fascinating answer. But, from helicopters, because I'm used to, traditional airplanes. But I'm thinking about some of these VTOLs that we're looking at and how they're going to interact with turbulence. Because I know, a big thing about turbulence is going to be the airfoil design and the wing loading and power loading. It's a very different formula around some of these VTOLs. Some of them will have multiple shrouded ducted fans or things like this when we're doing this.
Yeah.
And any thoughts on that? How that might affect passenger or cargo?
Yeah, I think we may have to see higher separation. I don't know. I will say that Beta Technologies has flown their conventional aircraft thousands of kilometers. They've flown into international airspace. They've flown I've seen them in the pattern at Montreal Airport. I don't know how they handled in turbulence. These are the things that we're going to have to. This is the reason we're doing this test arena. So we're going to be issuing a report out of this test arena with a variety of KPIs, and I'm sure that will be one of them. And then that's back to our approach: is start in remote locations, prove out the technology, understand it as you guide along, rather than just throwing 50 aircraft into a condensed area doing an urban mission. I think that could lead to certainly problems. I hope we do get there. I hope we get a chance to turn our iPhones on and hail an air taxi, but we've got to go through. We got to solve problem 1, 2, 3, and 4 before we get there.
Before you
And
get to problems 5, 6, and 7.
Yeah, and I think there's some very interesting, viable business models to support that early stages and that approach, which should justify a further investment in infrastructure and air traffic management and then in production. I mean, think about these vehicles today. Joby, Archer, and Beta have either built or are in the very final stages of building their production facilities in various locations in the United States. 300 aircraft a year, 600 aircraft a year production capabilities once they get to full scale. That's just the tip of the iceberg. You're going to have to start looking at automotive scale production, or at least automotive geographically diverse production, because moving these vehicles across around the world is not going to be easy or cheap, which could, in fact, if you have to move one of these aircraft by sea, it's going to be 10%. Shipping costs will be 10% of the asset. That's going to negate some cost savings for sure.
It is, and I love what you brought up around infrastructure, air traffic management. We're bringing on a couple experts here in a few weeks to really dig deep into that topic, because that is going to be an enabler as the platforms come out. You got to be able to have an infrastructure that allows us to use them. But right. I'd like to dig in, because you guys announced you're going to be using Elroy L. Chaparral platform. Fascinating platform. I've done a lot of research on it. We're actually looking at possibly using it in an application that we're going to be maybe partnering with. But I would love for you to talk about it. It's your only UAS platform that you're going to be bringing on currently. And so tell us your thought behind it and how you're going to be using it. And where does it solve some real world problems for your customers?
Well, it's really in moving material to and from offshore oil platforms. They today, most material that goes offshore goes by ship. It's very rare they carry cargo in the helicopter because the helicopters are really expensive. So everything goes out in a very well planned environment. It's when you have what's called when you have some sort of a mechanical failure or emergency on offshore where you actually either have to charter a helicopter specially and then move it off. So most of the energy companies that we've talked with are very keen on doing this, and you also have this concept that it's got to be big and heavy. Most of the stuff that they move for these emergency requirements is less than 200 kilos. So 99% of their flights, the 90% of the stuff that they're moving off on an emergency condition is relatively small.
But these are probably mission
And
critical parts. A pump's not
mission
working, a
critical
drill's not
parts.
drilling.
Yeah.
They're not.
Many
I mean,
times
this
it's
is
a
like
chip.
we got to get
It's
this
a-
thing back
yeah,
on
it's a gear.
ASAP. We're losing millions.
So how can we do this more efficiently? And that's where Chaparral fits in. The other thing that was really interesting for us with Chaparral was it's because of its hybrid electric, so you have a little bit higher payload and range capabilities. You know, you're putting fuel on it using a small turbine engine. The payload capabilities and the pod that's going to be utilized really lends itself to a lot of different other mission profiles. So you can put mission equipment on it for search and rescue. You can be mission equipment on it for surveillance, noxious gas sniffing. All those things kind of fit into that. So we really saw it as a fit for our energy customers and for our government services.
Yeah, and I have a question for you because S-Works just came out. They've been doing a lot of feasibility studies on electric and hybrid. And for a lot of the military applications, what they came to the conclusion of is currently traditional power, turbine, is what's going to give VTOLs both payload and range. Of course, that's what we're focused on in other companies. And I'd love for, with your background in helicopter operations, what you're learning about AAM currently, where do you see kind of that capacity as it matures, fitting into either a business model like Bristow's or just, use cases that you might see coming out 3, 4, 5 years down the road?
Well, back to the case of helicopters, very high CapEx, very, very high OpEx and complex. And the reliability is nowhere near what it is in a 121 carrier world. So it's not as reliable as a 737 or A320 family, right? So that means you have to overcapitalize and have more aircraft than you need to support your customers on a daily basis. So let's say for every 5 helicopters you have on contract, you need at least 1 extra for backup. That's just a nominal number. It's not that bad. So we overcapitalize, plus they're really expensive. And if we can get this technology to the point where its range and payload improves, and even just if its range improves, you can make some arguments where if a 6-passenger eVTOL is $4 million and it costs $800 an hour to operate versus a $40 million S92 that carries 19 passengers, well, do the math. You could buy 4 for 16, and the OpEx stays the same. You got a little bit higher. You'll have more flight crew, but that's a big value chain. So that's going to be more than 5 years before we get there and get offshore. But there's capabilities there where you might see more aircraft with less payloads, but at a lower cost point, and then you get the sustainability side of it. I think there's really some opportunities there for that to really replace helicopters over time once we get the confidence.
So it sounds like the way you're looking at both helicopters through AAM is what's this combination of both CapEx and OpEx? How do I optimize that to deliver a really appealing solution to my customers while also being, hitting the margins that you guys need to do internally at Bristow? Is that fair?
Yeah, that's fair. Yeah, that's fair.
Well, as we come in and kind of land the helicopter, so to speak, first of all, Dave, do you have a helicopter rating?
No.
Okay.
No.
One of these days,
been an engineer. I've flown many. My wife asks me all the time why we don't have an airplane. I said because I'm a type A person. I don't have the time to stay current, and I know what it takes, and I would afraid I'd hurt myself.
Yeah. Well, I've been I still fly, but it's still on my dream board to get a helicopter rating. So I'm going to be doing that here, hopefully in the near future. But as we set her down on the landing pad, just any final thoughts you'd like to leave with us? And I just really appreciate your time. This has been a really interesting conversation.
I appreciate you having me. It's been a joy, and I hope I was able to impart some of the things that we've been the ideas we have. Yes, so I guess things I like to part of is watch us the second half of this year. I'm very excited to be able to participate in this test arena that Bristow is going to do, along with Beta and Avinar and EASA and the Norwegian CA, really leading the pack there. It's going to be, there's been a lot of stuff with AvWorks done. There's been a lot of demo flights, but there's nothing been on a sustainable side of long-term different environments. It's really going to prove out electric propulsion systems, I think. So watch that. I'm very excited about it, and that will allow us to bring really this to reality. We're in a revolutionary time in aerospace. Bristow is going to apply our evolutionary learnings and intellectual property to it to help this start. So it's going to get started. It's going to happen, and I really want to wish the companies that are going to try to certify aircraft either this year or next year all the best. We think that the whole industry can succeed and needs to succeed. We need to collaborate and make this happen.
Yeah, I would agree totally. I mean, our entire mindset is let's help everybody succeed because there's so much opportunity here. There's so much innovation happening, but also on the business side, there's so much need. Like you're talking about, right? Instead of buying one helicopter, if I can buy 3 or 4 that now are multi-purposing everywhere, but all of a sudden it's a force multiplier from a business case.
Great point. Yep.
It is. And I'd love to have you come back in the second part of the year as you guys are getting results out of Norway, even if they're preliminary, just even talk about your experiences, or even if you're starting to deploy the Chaparral. Dave, we'd love to have you come back on anytime and just share what you're doing and what's going on at Bristow and just give everybody an update because, you're out there operating in the real world, making things happen. And you know what? That's where all the work that all these companies are doing is to facilitate financial and client success from companies like yours. So.
Well, thank you. Again, I'm happy to come back. I like to talk. I was a helicopter salesman, so you'll have to shut me up and appreciate the opportunity and look forward to speaking again soon. Okay.
Well, if I get down to Houston, I'll make sure I look you up and we'll grab dinner or a beer.
Sounds good.
Okay. Cheers. Have a great one. Thanks, Dave.
Bye-bye.